This is section 1.1, number 17, a problem that I didn't discuss very much in the lecture or in discussion. So I just wanted to fill in some of the gaps here and read through it. It's a very basic problem, but it takes a little getting used to in that it's asking you to adjust an actual model, and it takes a while to develop some intuition for. I'm going to read through it. Suppose a species of fish in a particular lake has a population that is modeled by the logistic population model with growth rate K, carrying capacity N. So here I've written it out 3 times, and we're going to adjust the model according to what is asked of us here. So it says adjust the model, assuming that 100 fish are harvested each year. So before I do it, and it's very straightforward, I'd like us all to feel comfortable with the idea of, suppose all we knew was that the fish population at time, the P of t represents the fish population at time t, and that initially at time 0, P of 0 is 1,000. And if I told you that I was going to harvest 100 fish each year, where T is measured in years, then the corresponding differential equation, if they're not growing at all, and all I'm doing is taking them away, then I would say to you that the rate of change of P is negative 100. What function satisfies this? P of t is equal to minus 100, t plus a constant. Since P at time 0 is 1,000, plugging this in, we have that if t is 0, I've got minus 100 times 0 plus c. That says that c is 1,000. And a corresponding solution would be this, the constant plus this. So this is unrelated specifically to, this is a different model, but I want us all to feel comfortable with what this is saying. I start with some constant fish population. I'm not going to allow in this model, unlike the logistic model, I'm not going to allow there to be any growth. All we're doing is harvesting. We're taking away 100 a year. And I want you to see that it leads to a function of this form. The constant is 1,000. And I want this to feel comfortable to you. If there's no growth in the fish population and I'm taking away 100 a year, then this model says at the end of 1 year we have only 900. At the end of 2 years we have 800, and so on. This is a linear model. As we answer the 3 questions, we're basically following the same principles. To adjust the model for some decrease in the population, all we do is subtract the amount that's being specified. So in part A, they're saying, hey, here's how our population is growing. It has a carrying capacity of n, so it won't surpass that. But we're going to harvest 100 fish a year, so all we do is subtract 100 from this model. In part B, it says 1/3 of the fish population is harvested annually, and so in part B, we don't change the model any other way other than saying we're going to subtract 1/3 of the population each year. And finally, the number of fish harvested each year is proportional to the square root of the number of fish in the lake And so here, we're just going to subtract. We're going to be decreasing by some proportionality constant. I have to use a different one. I apologize. I can't use k again. So let's use alpha. And the square root of p. And that's all we're looking for. And that's our, these are our three answers for number 17. Thank you.